Hello students, now I am going to speak about refrigeration cycle, especially about vapor compression cycle. First of all, let us understand the difference between cooling and refrigeration. Cooling is that process in which a hot body which is hotter than to that of surrounding loses heat and ultimately becomes in equilibrium with the surrounding temperature. For example, suppose there is a body at 50 degree centigrade and surrounding temperature is 35 degree centigrade. Then in case the body is left in atmosphere, then it will lose heat and ultimately become in thermal equilibrium with the surrounding, and its temperature will also become 35 degree centigrade. So cooling is losing of heat by a body or by a system above atmospheric temperature. But in refrigeration, the temperature of body is brought down below the atmospheric temperature. For example, suppose a body is there at 35 degree centigrade, and in case we want to cool it down to 15 degree centigrade, then this process is called as refrigeration. So cooling is heat lost by a body above atmospheric temperature, and refrigeration is heat lost by a body below atmospheric temperature. Now let us understand the difference between boiling and condensation. Boiling is that process in which at boiling point a liquid changes its phase to vapor form. Boiling point is that temperature at which the liquid starts changing its phase to vapor form. For example, in case water is there at 1 bar pressure, then the boiling point of water is 100 degree centigrade. In case latent heat is supplied to water, then the water will convert to vapor form from liquid form. So this process is called as boiling. Condensation process is just reverse of boiling process. In condensation, a vapor changes into liquid by rejecting latent heat, because we know that a liquid changes to vapor by absorbing latent heat. So in case the reverse process is to be happen, then we have to make the vapor to reject its latent heat to convert to liquid form. And again, the condensation also takes place at the boiling point. Now let us understand the variation of boiling points of different liquids at different pressure. It is a natural phenomena that in case we increase the pressure over any liquid, then its boiling point also increases. For example, what is the boiling point of water? Your answer might be 100 degree centigrade, but actually it is not there. The boiling point of water, and not only water, all the liquids depends on the pressure applied over it. In case the pressure applied over water is 1 bar, then its boiling point is 100 degree centigrade. In case the pressure applied is 2 bar, then its boiling point becomes 120 degree centigrade. In case it is 5 bar, then its boiling point becomes 151 degree centigrade, and we can even boil the water at 2 degree centigrade in case the pressure applied over it is below atmospheric pressure, that is vacuum pressure, that is 0.00685 bar. So it is not like that any liquid is having a fixed boiling point. The boiling point varies with respect to the pressure applied over the liquid. Now let us take an example of ammonia. Ammonia at 1 bar pressure boils at minus 33 degree centigrade. Means in case the pressure applied over ammonia is 1 bar, then the boiling point is far below the freezing point of water. But in case over same ammonia the pressure applied is 20 bar, then its boiling point become 50 degree centigrade. Thus we can see that ammonia is also behaving as like that of water, means we are increasing the pressure, then the boiling point is also increasing. In case the pressure applied over ammonia is increased from 1 bar to 20 bar, then its boiling point changes from minus 33 degree centigrade to 50 degree centigrade. Now let us understand when a liquid will boil and when a vapor will condense in case left in the surrounding. See, in case the surrounding temperature is more than the boiling point of liquid, then liquid will boil. For example, we know that boiling point of water at 1 bar pressure is 100 degree centigrade. So in case we want to boil of water, then we have to heat it up to the temperature of 100 degree centigrade. Now in case water is left in the surrounding, then it will not spontaneously boil until and unless the surrounding temperature is 100 degree centigrade. To boil of water, the atmospheric temperature should be above 100 degree centigrade, otherwise the water will not boil. In general, the atmospheric temperature over earth never becomes 100 degree centigrade. Therefore, water remains in liquid form in case it is in atmosphere. For example, lakes, rivers, seawater is in liquid form in atmosphere. Although evaporation takes place with water, but the phenomena of evaporation of water is different to that of boiling. Secondly, when a vapor will condense, the vapor will condense only in case the temperature of surrounding is less than to that of the boiling point of the vapor. Thus, we can say that a liquid will spontaneously boil in surrounding in case the surrounding temperature is more than the boiling point of liquid, and a vapor will spontaneously condense in case the surrounding temperature is below to that of boiling temperature or boiling point of vapor. Now let us do an experiment. We can see that there is a piston cylinder system in first diagram in which there is ammonia at 1 bar. At 1 bar, the boiling point of ammonia is minus 33 degree centigrade. Suppose the surrounding temperature is 30 degree centigrade. So in such case, what will happen? Since the boiling point is less than to that of surrounding, so the ammonia will be in vapor form. Now suppose the piston is moved so to compress the ammonia to 20 bar. At 20 bar, the boiling point of ammonia is 50 degree centigrade, which is greater than to that of surrounding temperature. So what will happen? Ammonia will condense to liquid, because we already discussed that in case the boiling point is more than that of surrounding temperature, then the vapor will condense. So the same thing is happening here. The pressure of ammonia is increased to 20 bar, so its boiling point has been increased, so it is condensed, and we know that whenever condensation takes place, then a vapor will reject latent heat. Now let's do an experiment. We can see in diagram A there is a piston cylinder system in which there is ammonia at 20 bar. We know that at 20 bar the boiling point is 50 degree centigrade. Suppose the surrounding temperature is 30 degree centigrade, so ammonia inside the piston cylinder system will be in liquid form. Now suppose this piston cylinder system is dipped inside a water container and piston is pulled, so that the pressure of ammonia inside the piston cylinder system again becomes 1 bar. In such case, the boiling point of ammonia will again fall and will be minus 33 degree centigrade. So what will happen? Since the boiling point is below to that of surrounding temperature, so ammonia will vaporize. But we know that for vaporization a liquid needs latent heat. So from where it will absorb latent heat? It will take the latent heat from the water. So by doing this, the water will cool down. Now suppose the piston cylinder system is again taken out in the atmosphere and the piston is again pushed, so that the pressure of ammonia inside again becomes 20 bar. So what will happen? Again the boiling point will increase, so it will lose the latent heat and become liquid. Now again this piston cylinder system is inserted inside the water container, and again the piston is pulled. Again it will vaporize and absorb the latent heat from the water. So by repeating this process again and again in a cyclic way, what will happen? Ultimately the temperature of water will cool down and the water will freeze. This is how we have made a very simple vapor compression cycle. This is what the principle of a vapor compression cycle. Now let us understand the principal diagram, the principal operation and components of a vapor compression cycle. We are taking ammonia as a refrigerant. We can see that in vapor compression cycle there are 4 basic components, that is the compressor, the condenser, the throttle valve and the evaporator. The job of compressor is to increase the pressure of the refrigerant. For example, we can see that ammonia vapor is entering inside the compressor at 1 bar. Now the compressor is increasing the pressure of ammonia to 20 bar. We know at 20 bar the boiling point of ammonia is 50 degree centigrade, and suppose the atmospheric temperature is 30 degree centigrade, because we know generally the atmospheric temperature remains below 50 degree centigrade. Now it is passed through a condenser. In the condenser it loses the latent heat and becomes high pressure liquid, because its boiling point is above to that of surrounding temperature. Now after passing through the condenser, it is passed through a throttle valve. The job of throttle valve is to reduce the pressure of the refrigerant. Here we are using ammonia as a refrigerant, so the pressure is been reduced to 1 bar. We can see 20 bar ammonia liquid is reduced to pressure of 1 bar ammonia liquid. At 1 bar we know that the boiling point of ammonia is minus 33 degree centigrade. So what will happen? It has to vaporize. Now it is sent to the evaporator. In the evaporator it takes the latent heat from its immediate surrounding and vaporize, and this vaporized ammonia is sent to the compressor again. Again the ammonia is compressed to 20 bar, its boiling point increases, it loses latent heat in the condenser, becomes high pressure liquid. It is then throttled to low pressure, that is 1 bar. At 1 bar the boiling point is minus 33 degree centigrade, so it is sent to the evaporator. In the evaporator it absorbs the latent heat and then again sent to the compressor. So by this way the temperature of evaporator falls down and refrigeration is thus achieved. So this is how our simple vapor compression cycle works. Now what will be the COP, coefficient of performance of vapor compression cycle? We know that the definition of coefficient of performance is desired effect upon input. Now what is the desired effect here in vapor compression cycle? The desired effect is cooling in the evaporator. So how cooling is taking place? By absorbing heat. So the heat absorbed in the evaporator by the refrigerant is what our desired effect is. Now what is the input to the vapor compression cycle? We know input is the work done by the compressor. So what will the COP or coefficient of performance or efficacy of the cycle? Efficacy of the cycle is equal to heat absorbed in the evaporator in a particular time interval divided by the work done by the compressor. We have used ammonia as a refrigerant in this vapor compression cycle which we discussed, but there are many refrigerants available for performing vapor compression cycle. For example, in our common household refrigerator, the common refrigerant used is R134A. Similarly, there are some other refrigerants available, for example R12, R11, which are chlorofluorocarbons. Even water can also be used as a refrigerant. but there is a different method for developing refrigeration effect by taking water as a refrigerant. Now I am going to speak about vapor absorption cycle, which is also a refrigeration cycle. First of all, let us understand a peculiar property of ammonia and water solution. In case we mix ammonia with water at low temperatures, means the temperature is at around room temperature, then ammonia is readily soluble with water. But in case we heat the solution, then the solubility of ammonia with water decreases and it liberates out from water with high pressure. So this property of ammonia and water solution, called as aqua ammonia solution, is being used for developing refrigeration effect by the help of vapor absorption cycle. Now let us see an arrangement of aqua ammonia solution, in which we can see that there are two vessels. One vessel is absorber, which is at colder temperature, and one vessel is the generator, which is at higher temperature. In the colder vessel, that is the absorber, there is a solution of ammonia and water, that is aqua ammonia solution. Now by the help of pump, we are transferring this solution to high temperature generator. What will happen? In the absorber, the ammonia was in mixed form with water and it was a strong solution. But in generator, what is happening? Since the temperature is high, so ammonia is being liberated out from water with high pressure. The water which is been free from ammonia in the generator is being returned to the absorber again by the help of a return duct. So by this way, the solution is circulating in a loop, that is absorber and generator. From the absorber, it is sent to the generator by the help of pump, and then the ammonia free water is returned to the absorber again by the help of return duct. Now continuously, if we will perform this cycle, then what will happen? All the aqua ammonia solution will go in the generator and the entire ammonia will be released from water, and water will come down without having any ammonia. So we can develop high pressure ammonia in the generator by this way. Now we know that in vapor compression cycle there are four basic elements, that is the compressor, condenser, throttle valve and evaporator. The job of compressor is to suck the refrigerant at lower pressure and to increase the pressure of it. This increased pressure refrigerant is sent to the condenser, where it loses latent heat and becomes high pressure liquid. After passing through the condenser, it is throttled to lower pressure and then it is passed through the evaporator. In the evaporator, it absorbs heat. The cooling load is subjected to the evaporator only. So in the evaporator, the cooling effect is achieved. Now this low pressure refrigerant is again fed to the compressor. In the beginning of lecture, we already discussed about the property of aqua ammonia solution, and we know that ammonia is also a sort of refrigerant. Now let us use this effect of aqua ammonia solution, this property of aqua ammonia solution, for developing refrigeration effect via vapor absorption cycle. We have to do nothing but replace the compressor with generator absorber system. We can see in the diagram of vapor absorption cycle that there is a generator, there is an absorber where there is a solution of water and ammonia at lower temperature. The temperature is low, so it is soluble. Now it is sent to the generator by the help of pump, and the generator is at higher temperature. So what will happen? The ammonia will release from water and develop a high pressure over water. Now what is the job of compressor in vapor compression cycle? We know the job of compressor is to increase the pressure. The same effect has been developed by the help of our generator absorber system. Now This high pressure ammonia in the generator is sent to the condenser. In the condenser, it loses heat, becomes high pressure liquid. It is throttled. This throttled refrigerant is passed through the evaporator to absorb heat and then again fed to the absorber to make the solution of absorber strong. Thus, we can see that this generator absorber system is replacing the compressor of vapor compression cycle, and by this way refrigeration effect is being developed. This is the basic principle of working of vapor absorption cycle. Thus, what we see that in vapor absorption cycle we are replacing the compressor by a generator and absorber system. The absorber is containing aqua ammonia solution. The temperature of the absorber is maintained cool by the help of circulating cold water by the help of a heat exchanger. Similarly, the temperature of generator is maintained hot by the help of circulating steam or hot oil via heat exchanger. So continuously the ammonia is coming from the evaporator and mixing in the absorber, and since in the absorber the temperature is less, so ammonia is being mixed with water forming a strong solution. It is pumped to the generator. In the generator the temperature is high, so the ammonia is again released with high pressure, and this high pressure ammonia is then sent to the condenser, then throttle valve, and then evaporator again. So actually the vapor absorption cycle is a different sort of vapor compression cycle. The difference is, in place of compressor we are using some another mode to increase the pressure of the refrigerant. Second thing is, since there is no compressor in vapor absorption cycle, so by the help of heat only, means to generate refrigeration effect we have to supply heat in the generator. So solar refrigeration system can be possible with using this vapor absorption cycle. Just we have to subject the generator to the heat of sun by solar concentrators or by any different mode.